Okay, let's solve the question largest rectangle in a histogram. So what this question says, we are given an integer array heights, that's this heights array, and it represents the histogram's bar height. So for each one it represents the height of the bar. Say let's say 2 is the height of this bar, then 1, then 5, then 6, and so on. Now, and the width of each bar is 1, that is this slide. This is 1 unit, each one is 1, and we need to return the area of the largest rectangle in the histogram. What is largest rectangle in the histogram? So we need to form rectangle in this histogram. For example, we can form one rectangle, this can be one rectangle, and imagine this can be another rectangle, this can be one more rectangle, for this can be another rectangle. Like this we need to form a rectangle which gives the maximum area here. So what is the area of rectangle here? Is length into breadth, right? What is length? Length is, we can consider it as height, and for each one it is 1 unit, right? If we consider, imagine we consider 2 here, this one and this one, this will be 1 plus 1, and height is 2 here. So this is nothing but the width of all the bars that we consider. So what is the answer for this one? Let me erase this. Okay, shit. Oh my god. Okay, what will be the answer for this test case? Let's see what and all the rectangles we can form. We will start from first. Okay, so if you consider 2 here, what is the rectangle that I can form from this 2? I can't go this side, right? So because I cannot form, because 1 is lesser. See, it will form this kind of thing. So this is not a rectangle, this is not a valid rectangle, so I need to stop here only. What about this side? There is nothing here, so this is just 2. So let's take maximum is, currently I have 2. Now let me move to next one. From 1, what I can form? Can I go this side? Or can I go this side? Yeah, I can go this side also, right? So let me go this side. I can go till here. See, can I go again? No. Let's take this as 0 height here, and this as 0 height here. Can I go this side? No, I can only go till here, and I'll move to right side now. Can I go here? Yeah, because 5 is greater, 6 is also greater. I can form 1. Okay, I can go, I can again go. Now it has become 0. We reach the end here. So I can form this rectangle, right? So what is the area of this rectangle here? See, I am at, this is 1, 2, 3, 4, 5, and 6 is the width, total width, and height is this one we consider from here, right? So total will be 1 into 6, that is 6 is the area here. Now let's move to the next one, next index. Next one is here, we have 5. Let me remove all this here, let me erase only. What happens when we consider 5? Can I move this side? No, it will cause like this. No, not possible. I can only go, I cannot go anywhere on the left side. Can I go on right side? Yeah, I can go here. Can I go again? No, because it can't form a valid rectangle. So this will be my area for when we consider 5. So what is the total area here? This is, height is 5, and this is 1 plus 1, 2. 5 into 2 is 10 is the area for this part. Now let's go to the next one. Next one is 6. Can I go this side? No. Can I go this side? No, we can't form any rectangle. So only this part is there. So area here will be 6 again. Till here, what is the maximum we have from? 10, right? So next move to the next one, 2. Can I go this side? Yes. Can I go this side? No, this is 0 area, nothing is there here. Can I go this side? Yes, I can go. Can I go this side? Yes, I can go. Can I go this side again? No, not possible, because see, one, if you consider 1, it cannot be a valid rectangle here. So I can for this one. What is the area for this? 1, 2, 3, 4 is the width, and height is 2. What is the area? 8. It is still lesser than 10, right? Now let's go to next one. That is the last one, 3. This one. Can I go this side? No, 0. Nothing is the area, so we cannot form rectangle on this side. Can I go this side? No, because again 2 is lesser, cannot form. So this is just 3. So maximum one that we found out here was 10. That will be the answer. See, here you can see this is the maximum one. Maximum area that we can form is 10. How do we solve this? From this we have understood that let's consider 1 only, right? We can move until we find the height something lesser than 1. Okay, let's consider this one, 1, right? Either I can expand towards the right side or left side. Till where I can expand? Until I found the height something lesser than the current one. So I can move. See, 5 is greater, so I can move this side. 6 is greater, I can move. 2 is greater, I can move. 3 is greater, I can move. Now it has become lesser. There is nothing here. We reached end and we consider it as 0. I can move till here. And here also 2 is greater, I can move this side. There is nothing here. I can stop. I need to stop here. This is the valid rectangle that I can form. So I can let's take another one. Let's consider 2 here. That will be more clear. So I'll consider 2, right? How much can I expand in right side as well as left side? 3 is greater. See, I can expand. Now nothing is there. I need to stop here. And this side, 6 is greater, I can expand. 5 is greater, I can expand. 1 is lesser. See, now I need to stop. So how much I can expand? One is on right side. Till I find first height lesser than current or reached end. This is for right and same for left also, right? I hope you understood this one. So what is this basically? We are just finding for right side the next smallest element. We find the next smallest element for each, and left also we find previous smallest element. This is NSE, previous smallest element. Yeah, why is this? Let me take another example with more heights. This will be more clear with another example. So let's say we have some height. Let's say this as 2, and we have all greater heights here. Let's not consider values. Let's just draw this diagrams. Can I expand to here? This side. Yes, I can expand. I can go on expanding till I find something lesser. Let me draw a few more heights now. Let's say I have this. I can again expand, but when I get this which is smaller than 2, I need to stop. I can't move here. If I take this is not a valid rectangle, right? So I need to stop. Here. Here I have found first height lesser than 2. Same when we do to the left side. For each height we find the previous smaller element and next smaller element. Now how to find the previous smaller element and next smaller element? We have discussed this in our monotonic stack video. If you don't know how to implement the monotonic stack, you need to rewatch those videos. It is there in the playlist. You can watch the next greater element, next smaller element, previous greater element and previous smaller element. Then this will be a cakewalk for you. It's a very simple approach, and we can find the next smaller element and previous smaller element for each index, for each height in O of n total time. So let me again paste this. So how does NAC, next smaller element, and previous smaller element help to solve this problem? Let's calculate this and see how it works. See, for 1 I can go, as I told, I can go till I found the smaller element. Let's take these and this as 0 heights, that is at -1 and that is at n. So we find the NAC and PSC. First I'll find the NAC here, next smaller element. So for 2, what is the next smaller element? That is 1. I'll store index instead of values here, okay? Let me write the indexes 1, 2, 3, 0, 1, 2, 3, 4, 5. Let me start from last only. For 3, what is the next smaller element? That is 0 height, that is at nth position. And we haven't found anything, means we'll reach the nth position and the height is 0 here. So I'll mark the index as n here. So for 2, what is the next smaller element? Again it is n. And for 6, what is the next smaller element? That is 2, which is present at index 4. For 5, what is the next smaller element? That is 2, present at index 4. For 1, what is the next smaller element? There doesn't exist any next smaller element in the given array, and we have assumed that at index n we have height 0, so I'll mark this as n. And for 2, what is the next smaller element? That is 1, that is at index 1. Now this is the NAC. What is the previous smaller element? That is PSC. Let's calculate. For 2, what is the previous smaller element? There doesn't exist any element, and we move to -1, that is height 0 here. So we mark this as -1. For 1, what is the previous smaller element? There doesn't exist anything, so we mark -1. So for 5, what is the previous smaller element? That is 1, that is at present at index 1. For 6, what is the previous smaller element? That is 5, present at index 2. For 2, what is the previous smaller element? That is 5 is not, because it is greater, 5 is also greater, 1 is smaller, that is present at index 1. And for last element, that is 3, what is the previous smaller element? That is 2, present at index 4. And I'll write height also here only. First was 2, then it was 1, then it was 5, then it was 6, then 2, and then 3. So how does this help in calculating the area? Let's see. So we have NAC and PSC. Imagine we have, let me erase this and this clearly. Yeah. How does this NAC and PSC help? Let's see. So for 1, let's take for 1 only. So let's take for 2. What is the PSC for 1? Previous smaller element. That is at index 1. Let me color this with different one. This is the previous smaller element. That is it at index 1. 3, 4, 5, 6, -1. And what is the next smaller element? Doesn't exist, index at 6, so we mark it as n, next smaller element. So what is the width that we can form here? See, just after this is the PSC, right? So just after PSC till here I can form 2. So just before NAC I can form till here. This is the rectangle that I can form, right? So what is the width of this? this is nothing but NSE minus PSE plus 1, sorry, NSE minus PSE minus 1, right? NSE minus PSE minus 1. This will be the formula to find the width of this part. So we subtract this minus 1 because it is index, so we will get the total width here. And what is the height here? Height is nothing but the index that we are considering. Here we consider 2, that is the height. 2 is the height for everything. So we get 2 here. We got the width as 1, 2, 3, 4. That's what we should get for 2. Let's see, let's verify whether we will get 1, 2, 3 and 4 here. So for 2 is present at 4th index, right? 0, 1, 2, 3, 4th index. We consider this. So height is 2 now currently. So NSE of index 4 minus PSE of index 4 minus 1 we will get as NSE is n, that is 6 minus PSE is 1 minus 1. What we will get? 6 minus 2, that is 4. So what is the area that we can get? Area is height into width, that is 4 into 2, we get as 8 is the area here. How do we calculate maximum out of it then? Let's do this for all indexes and count the keep track of the maximum. That's what we are going to do for all the elements. Okay, let's trace this. So for first one, what we will get? First element is, that is height is 2. What is the width we will get? That is 1 minus minus 1, that is 1 minus minus 1 minus 1, that is nothing but 1 plus 1, it will become 2 minus 1 is 1. 1 into 2 area is, that we will get is 2. So our current maximum is 2. Now we move to first index. So what is there at first index? Let's calculate again. For first index, again same we will do n minus minus 1 minus 1. So we will get n plus 1 minus 1, that is nothing but n, which is 6. 6 is the width and height is 1, area is 1. Our maximum was 2, 2 is greater than 1, so maximum is not updated. We move to next is 5 here. So we do for 5, again we calculate 4 minus 1 minus 1. What we will get? 2. What is the height? We get as 5. 5 into 2 we get 10. 10 is the area. 10 is greater than 2, so we update it to 10 here. Let me erase this again. Let me open new one only and draw there. Okay, now we are at 6. For 6, what it will be? So again, if we do the same, for 6 there was nothing, so let me write the indexes 0, 1, 2, 3, 4, 5 and 6. For 6, the next smaller element was at index 4, right? 4 minus, so previous smaller element was at index 2, right? So that is 2 minus 1, that is 4 minus 2 is 2 minus 1 is 1 is the width, that is the one rectangle that we can form. We will get the answer as 6 here. So we do the same for this, everything. At last we will get the maximum as 10 here. I hope you understood the approach. Let's go to the I'll write the pseudocode on how to solve this. So let's say we have the functions. I'll write the two functions. Let's say it will return the list, it will return this list, and it will find the next smaller element for the given array. This function will find the and return the NSE, and I'll write another function. Let's say this, it will find the PSE and for the given list or array, and this will return the NSE and PSE. I'm not going to write the code again because this is just the same code as next smaller element and previous smaller element that I have explained in the previous videos, so you can watch that videos. Now I will go to the next part, which is calculating this. So what we do is we find the list of NSE equals to, we'll write this function as find NSE, find PSE. Okay, find NSE of height. This will give us the next smaller element. Let's say we have this PSE, find PSE of the height. We will get the NSE and PSE. Now what we do is we consider each height, right? So we loop through I equals to 0 to n minus 1, and current height is nothing but height of I. This is nothing but height, and we need to take another example as max height, which is nothing but 0 initially. Now we need to find the width. What is the width here? As I said before, it is nothing but NSE of I minus PSE of I minus 1. This will give me the width. So what is the area here now? Area is nothing but height into width. So now we take the maximum, that is max height is nothing but max of area comma current max height, that is max height. This is what we get, and at last we return the max height. So one thing that we need to take care of is in the next smaller element, previous smaller element. Previously in my playlist, as we have seen, we have stored the values inside stack, right? But here we need to store the indexes. I explained why we need to store the index here, because we need to calculate the width. With values we can't calculate the width, so we need to store the indexes. That's NSE of I minus PSE of I minus 1. So we are calculating the indexes here, right? So how do we do this? Let me explain with example. So instead of pushing stack dot push of array of I, now what we can do here is we can just push I here. This will just push the index to stack. Now stack will only store the indexes. So how do we act? How does the while loop need to be changed? This is same, and previously what we are doing, stack dot top, we are finding the greater than or equals to array of I, we were popping, right? Now what we need to do, previously we had values, that was stack dot top. Now we have index, so we need to check the element present at that index, right? So we need to access it through this. So this is the only change that you need to do in the code. Now what will be the time complexity? So for NSE it is O of n, for PSE again it is O of n, and we loop through each height and calculate NSE minus PSE minus 1 and multiply, calculate area, find maximum, that is O of n again. So what is total time complexity is O of 3n. What is the space complexity now? Space, we don't need extra space for the calculation of heights and all, only for NSE and PSE, that is O of n space for storing NSE and PSE, that is O of 2n for space complexity. I hope you understood the approach. If you understood the solution, please hit the subscribe button and like the video. Thank you so much.